I'd like to go over graphing with the quick graph method of slope-intercept form today. Reviewed some of the homework. Some of you have it, and some of you need a little practice. So let's practice. When I look at an equation and I see it's in the form that I'm looking for, which is again y is equal to m times x plus b, they're asking us to graph using this form. Well, I need two pieces of information. It's called the slope-intercept form of a line. And if I'm looking at slope-intercept form, I need those two key pieces of information. Slope, which in this case is a negative 3 over 2, and the intercept, which is b, which is 3. Look at your graph. To start graphing this equation, we always start with the y-intercept. That's a point on the y-axis. So remember from graphing with intercepts, when x is 0, in this case y is 3. Count up from the origin, 1, 2, 3. Now I look at my slope. My slope tells me how many units to rise and how many units to run. Well, this one is going downhill because it's negative. So I'm going down 1, 2, 3, and over 1, 2. I can stop at 2 points, but I know that slope is constant, so I can go down 1, 2, 3, and over 2. As I mentioned at some point in the last session, that if your graph doesn't allow you to go in the direction you need to, you could always go in the opposite direction, and I'd still go 1, 2, 3, and over 2. And now you can see a more defined line, and you can just take these points and connect. Once we connect the points, we have our line. We notice that it is going downhill, which means that it has a negative slope, and negative slopes also have a negative number, which in this case was a negative 3/2. On to another problem. Y is equal to negative 2/5 x minus 1. Identify your slope. Identify your y-intercept. Once again, my slope is negative. It'll go down and to the right. Where do I start graphing? Always from the y-intercept, the point on the y-axis. I'll now count down 2 and over 1, 2, 3, 4, 5. So it's rise, which is either up or down, run. Rise over run. I have 2 points. I will draw the line, arrows at both ends, and I have the graph. So far, all of my equations have been in the proper form. No need to rewrite anything so far. Next problem, identify your slope. Identify your y-intercept. Start your first point at that 2 on the y-axis, and then we count up 1 and over 1, 2, 3, 4. And there's our graph. Positive slope, positive 1/4. There was one on the homework last night that resembled something like this. And I identify my slope. Now when it went to identifying the y-intercept, some of you told me this, and your graph looked like this. And there was your graph. Error analysis time. What went wrong with this? Well, think back for just a moment. If my equation is y is equal to mx plus b, and m is my slope, which is 4/3, and I look to see that there is nothing next to it, my y-intercept is 0. Think back to section 4.5. This is a model of direct variation. Y is equal to kx, and therefore it starts at the origin. So let's go back and think about that. Now that I know that there is no other particular number for the y-intercept, which means it crosses through the origin, I count up 1, 2, 3, 4, and over 1, 2, 3. And there is my graph. I'm hoping after these few examples, it's a little bit easier. Now there's always something to add, and what we're adding on today is called the parallel lines. When I'm looking at parallel lines, there are two lines, as you might recall, that never intersect. And the key thing to this is to remember that parallel lines have the same or equal slopes. So let's do a little proving for this to be true. I give you an equation or line 1, and let's graph. Always start at your y-intercept, 1, 2, 3, 4. We'll count up 3, 1, 2, 3, and over 1. Here's line 1. Not my best line once again. I will try that a little bit better. Let's see if that's a little smoother. Okay. Now let's look at line 2. Y is equal to 3x minus 1. Well, I'm going to start my y-intercept at negative 1 and count up 1, 2, 3, and over 1. And I'm going to now graph the second line. And even though they're not exactly straight, you can sort of get the idea that these lines should never intersect because they have the same slope. We'll do more on this, and sometimes we have to look at lines, and two different lines again in the same plane are parallel if they do not intersect. In the coordinate plane, these two vertical lines are parallel, and any two non-vertical lines are parallel if and only if they have the same slope. So that's an important statement there. Looking at lines A, B, and C, which of the following lines are parallel? Well, I can't do anything with this problem until we write them into slope-intercept form. So I want you to take a moment and solve for y. Then we can compare the slopes. That's where we're going to pick up in class